Regardless of the size of the construction site, builders and subcontractors will at some time require electrical power. The availability of power on a job site means all manner of power tools can be used. Site offices and amenity buildings depend on power to run office equipment and air conditioning units. Security lighting requires a reliable power supply. Temporary power can be obtained from the local electrical supply authority. This involves written application and payment of a fee. The authority then allows connection to an on-site switchboard supplied by the builder. On a small building site, extension leads are run from this main board directly to power tools. On larger sites, power is distributed from the main switchboard to a series of sub-boards. These sub-boards then become the distribution points for electricity to the power tools. All electrical connection and wiring must be carried out by a licensed electrical contractor. The code stipulating electrical practices for construction work includes correct setup and usage of switchboards, generators, extension leads, and earth leakage devices. Non-compliance with the code will incur heavy fines. Switchboards are commonly housed in galvanised boxes. The hinged lid is rebated over the box to weatherproof it. The box must be capable of being locked when not in use. Care should be taken to ensure leads are not damaged when closing the lid. Main switchboards are securely mounted on a temporary service pole firmly fixed in stable ground. Wet areas should be avoided by locating the pole in elevated, well-drained ground. Supply may be either underground or by aerial cable. The location of the pole should not obstruct on-site traffic or material storage. On small building sites, power is supplied by extension leads from the main switchboard directly to tools. Larger construction sites are broken up into convenient areas. Each area is serviced by its own sub-board mounted securely on a temporary support. Tools are then operated using extension leads from the sub-boards. Sub-boards must be isolated and all boards locked at the end of the workday. Construction wiring must be suitably identified. General power outlets must be protected by an earth leakage device. Each outlet should be controlled by a double pole switch. Conventional power points use a single pole switch operating only in the active wire. For extra safety, double pole switches in construction site power points operate in both the active and the neutral conductors. Portable generators are another way of supplying temporary power to a building site. To choose the correct generator, the number of tools to be used at any one time must be known. Generator output is expressed in volt-amps or watts. By adding up the wattage from the compliance plate on each tool, the combined wattage is calculated. A generator which exceeds this total is chosen. This allows a safe reserve of power. Tools exceeding generator capacity could result in damage to both generator and tools. If the generator has an earth terminal, it must be correctly earthed. This is done by driving a metal peg into the ground and wiring it to the earth point. Should a fault occur, this allows the electrical current to take the path of least resistance to earth. An earth leakage or residual current device should always be fitted in line and tested. In a work cover safety alert, authorities have pointed out that earth leakage device protection may not work with generators. While the earth leakage device test button may appear to indicate there are no faults, it only monitors the internal circuitry of the device itself. It does not test the full wiring of the earth leakage device in conjunction with the generator. The residual current device and the generator must be checked in combination. Authorities recommend using a special purpose RCD test unit to ensure the residual current device will function safely in combination with the generator. Combustion engines exhaust toxic gases, so generators should not be used in enclosed spaces. Power from a portable generator is equally as dangerous as mains power. Operation in wet conditions could cause fatal electric shock. 240-volt extension leads consist of an outer case of insulation containing 3 multi-stranded conductors. These 3 conductors or wires are encased in colour-coded insulation. The maximum length of an extension lead and its capacity to carry electrical current are determined by the cross-sectional area of the conductors. This cross-section is measured in square millimetres. The commonly used wire sizes are 1, 1.5 and 2.5 square millimetres. Extension leads are usually 10 amps or 15 amps. On a 15 amp lead, the earth pin is larger than the pin on the more common 10 amp lead. A 15 amp plug will not fit into a 10 amp power point. A 10 amp lead with a conductor cross-section of 1 square millimetre has a maximum length of 25 metres. With the cross-section of the conductor increased to 1.5 square millimetres, the 10 amp lead can be lengthened to 32 metres. Using the same 1.5 square millimetre cross-section in a 15 amp lead restricts the length to 25 metres. However, by increasing the cross-section to 2.5 square millimetres, the length of the 15 amp lead can be extended to 40 metres. Plugs and sockets used on extension leads and tools must have either a transparent case or be of the moulded type which cannot be rewired. Extension leads and equipment should be inspected, tested and tagged regularly in accordance with the Code of Practice. Flexible extension leads must be protected by an earth leakage device at the last point of permanent wiring. Leads supplying more than one tool must distribute power through a multiple outlet, having overcurrent protection as well as earth leakage protection. The total power drawn from a multiple outlet board cannot be greater than that supplied to it by the extension lead. For example, a 10 amp lead supplying 2,400 watts can only support the simultaneous operation of tools drawing no more than 2,400 watts. On construction sites, fittings such as double adapters and piggyback plugs must not be used. The earth leakage device on multiple outlets should be checked before each use. When extension leads are run out, they should not be left coiled. When current is passed through coiled leads, a dangerous build-up of heat can occur. Extension leads are subject to potential damage on busy building sites. Suspending them at regular intervals prevents sag and keeps them safely away from water and traffic. Where this can't be done, on-ground leads must be enclosed or protected. Whether the project is a large construction site or a small cottage, the supply of temporary power must be carried out in accordance with the Code of Practice. Observance of the code not only makes for a safe workplace, but also avoids costly fines.